All right, let's talk about the internet. Not just the websites and apps we use every day, but what's really going on under the hood. How does it actually work? We're going to peel back the layers on this surprising journey from point A to point B. Let's get into it. So, to really get our heads around this, I'm going to start with a pretty weird question. Have you ever thought about how sending an email is, well, a lot like taking a flight on an airplane? I know, it sounds kind of random, but stick with me here, because this one idea is the key to understanding the absolute genius of how the whole internet is built. You see, to appreciate the solution, you first have to appreciate the problem. And the problem the internet's designers faced was just massive. They had to build a system that could connect the whole world with all its different parts and somehow make it all work together flawlessly. I mean, just look at all this stuff. The internet isn't one single thing. It's this huge, chaotic mix of pieces. You've got your computer or host. You've got routers that act like digital air traffic controllers zipping data around. You've got physical links, cables, fiber optics, radio waves. Then there are the applications, the protocols, which are just the rules of the road, and all the hardware and software that has to play nice. So how on earth do you manage all that chaos? Well, that brings us right back to our airplane analogy. Because if you think about it, air travel is also an incredibly complex system, but it's one we kind of get. And it turns out it's the perfect way to understand how the internet brings order to all that digital chaos. Think about the last time you took a flight. To you, it probably felt like one single thing, your trip. But it's actually a whole series of separate events, right? First, you buy a ticket. Then you check your bags. You go to the gate and get on the plane. The plane takes off, it flies its route, it lands, and then the whole thing happens in reverse. Each of these steps is its own little world. And here is the absolute key. Each step is its own separate service. The person selling you the ticket doesn't need to know how to load the bags. And the baggage handler, they don't have a clue how to fly the plane. And the pilot, well, they're not worried about which gate you'll arrive at. Every part of the system just does its own specific job and trusts that the next part of the chain will do its job too. And that is exactly how the internet works. It's not one giant, monstrously complicated thing. It's a system of independent services, stacked one on top of the other. And in the world of computer networks, we call these layers. This layered system has a name, the Internet Protocol Stack. It's a really clever way to take the enormous task of global communication and break it down into 5 smaller, more manageable jobs, one for each layer. So let's run through them real quick from top to bottom. Up at the top, layer 5, the application layer. That's the stuff you actually see and touch, like your web browser or your email app. Drop down a level, and the transport layer acts like a personal courier, making sure your email gets from your email program to the right email program on the other side. Then you've got layer 3, the network layer. This is the master GPS of the internet. Its job is to figure out the entire route across the country or the world, from your machine to the destination. Below that, the link layer, layer 2, just handles the very next hop, like getting data from your laptop to your Wi-Fi router. And finally, at the very bottom, the physical layer does the grunt work. It turns all that data into actual electrical pulses or flashes of light and sends it down the wire. Okay, so that's the theory, but what does this journey actually look like for a piece of your data? Let's follow a single message as it travels down through all those layers on its way out to the world. Let's say you're typing up an email. The actual words you write, that's your message. We'll just call it M for short. It all starts right there at the top, in the application layer. So the application layer hands your message M down to the transport layer. Now, the transport layer can't actually read your email. It doesn't care what it says. Its only job is to wrap M in a little bit of extra info called a header. We'll call it HT. Think of this like putting your letter into an envelope. This whole package, your message plus the header, now has a new name. It's a segment. But we're not done yet. The transport layer then passes that entire segment down to the network layer. And what does the network layer do? You guessed it, it does the exact same thing again. It takes the whole package and wraps it in another header, HN. This one has the global addresses, like the source and destination IP. It's kind of like putting that first envelope into a bigger shipping box and slapping the full street address on it. This new, even bigger package is called a datagram. Okay, one final wrap. The network layer passes that datagram down to the link layer. It adds one last header, HL, with instructions for just the very next stop on the trip, like the address of your home router. This completed package, the whole shebang, is now called a frame, and it's finally ready to be sent. This whole process, this wrapping of a message in layer after layer after layer of instructions, it actually has a name. It's called encapsulation. And it's really the core organizing principle of the whole internet. Each layer adds its own special set of instructions that only its counterpart, its twin on the other end of the line, knows how to read and understand. Okay, so I know what you might be thinking. This sounds incredibly complicated. All this wrapping and unwrapping, doesn't that seem really inefficient? Well, this is where the real beauty, the real elegance of the design shines through. It all boils down to one incredibly powerful idea: modularity. This right here shows you why this is so brilliant. Because each layer is its own little world, you can completely change or upgrade one layer, and the others, they don't even know it happened. Think about it. When Wi-Fi was invented, that was a revolutionary change to the physical and link layers. But did you have to get a new Wi-Fi-enabled web browser? Of course not. Your application layer just kept doing its thing, totally oblivious to the fact that the fundamental way your data was flying through the air had completely changed. And that is the big takeaway here. This layered, modular structure is what makes the internet so unbelievably resilient and adaptable. It means people can invent brand new applications, or faster ways to move data, or smarter routing systems at any single layer, and they don't have to rebuild the entire internet from scratch to do it. It's why it's been able to evolve for decades without breaking. So the next time you hit send, just for a second, picture that incredible journey. Your message getting wrapped in one digital envelope after another, passed down the stack, and then shot across a global system so flexible and so elegant that it grew from a tiny experiment into something that connects pretty much all of us. This design has worked for over 50 years, which really makes you wonder, what's next? What do you think the next layer of the internet will be?